Have you been stuck trying to calculate the total resistance or voltage drop in a series circuit? This video is for you. I will break it down step by step with two solved examples so you never struggle again. And hey, if this is your first time of coming across my video, I stand by the name The Smart Voltage Guy, and on this particular channel I teach engineers, electrical physics students and electrical or electronics engineer on how to analyze electrical complex circuits, electrical circuit analysis and electrical circuit theory. So this is the perfect place to start. I will teach you all you need to know about circuit theory analysis. So all you need to do is to subscribe to this channel so that whenever I upload a circuit tutorial video like this, you will be notified. I mean subscribe now so you don't miss out on my next upload. Okay, let's break it down now. Okay, what is series circuit? A series circuit is a type of circuit which components are connected end to start, forming a single path for current to flow. Okay, let's say we have this as a resistor. This is a resistor, and this is a resistor also. Let's call it a resistor R1, and let's call this resistor R2. You see, this is the starting terminal of what? Resistor R1, which is the starting terminal. When we write start, is the starting terminal of resistor R1, and here is the what? Ending terminal of what? Resistor R1. And this very particular point is the starting terminal, which is S, or what? Resistor R2, and the ending terminal, which is what? E, or what? Resistor what? R2. So when elements or components are connected end to start, when the end of resistor R1 is connected to the starting terminal of resistor R2, series circuit is being formed. So when these two terminals is connected, this type of circuit connection is called series circuit because it is connected to the ending terminal of resistor R1 and to the starting terminal of resistor R2. So the same amount of current flows through the resistor. So that is how a series circuit works. When two or more components are connected end to start, forming a single path for current to flow. Okay, what are the properties or behavior or characteristic of a series circuit? From this circuit, we can draw it like this and draw a voltage source. We have our source current and our supply voltage. One of the characteristics of a series circuit is that the same current flows through all components, which means that in a series circuit, current is the same. The same amount of current flows through all the components, which means it is this same supply current I that flows through resistor R1 and resistor R2 and back to the battery. That is how a series circuit operates. Okay, another characteristic or behavior or property of a series circuit is that the voltage drop across the individual resistance differs. The voltage drop across the individual resistor differs. That is one of the characteristics of a series circuit. The voltage drop across resistor 1 is different from the voltage that will drop across resistor R2. And the question is why? The answer is because voltage drop depends on resistance. It depends on the resistance value of that resistor. That is what will determine the amount of voltage that will drop across the individual resistor. Then another characteristic, from that characteristic, we can write that the total supply voltage, which is VT, is equal to the sum. VT is equal to V1 plus V2 from that word characteristic, which states that the voltage drop across the individual resistance differs, which it will be what? V1 will be equal to what? Vt will be equal to V1 plus V2. If we sum these two supply voltage, it will give us what? The total what? Voltage. Then another characteristic of a series circuit is that the total voltage is the sum of the individual voltage drop across the individual what? Resistor. The total voltage is the sum of the what? The voltage drop across the individual what? Resistor, which means, which is this, I just explained that Vt, which is the total voltage, is the sum of the voltage drop, which is the voltage that we drop across resistor R1, which is V1, and the voltage that we drop across resistor R2, which is V2. So that is what? The total supply voltage. It will be the sum of voltage drop across the individual resistance, which is V1 plus what? V2. Then another characteristic of a series circuit is that the total resistance is the sum of all resistors. The total resistance is the sum of all the what? Resistance in a series circuit, which means the total resistance in a series circuit, which is ROT, is the sum of the individual what? Resistor, which means it will be the sum of the word resistor R1, which is R1 plus what? R2. The total voltage, the total resistance ROT is the sum of the individual what? Resistance, which is the sum of what? Resistor R1, resistor R2. So they are the what? Properties or characteristics or behavior of a series circuit. Okay. Let's solve this example together. From the circuit above, we are given R1, R2, and what? R3, and 2 ohms for R1, 3 ohms for R2, and 7 ohms for what? R3. And we don't know the voltage drop across the individual resistor, because voltage drop across the individual resistor in a series circuit differs. And the total supply current is I, and we have a check source voltage what? Supply, and we are asked to find what? ROT, which is the total supply what? The total what? Resistance in the circuit. So let's solve it. Let me clean here. So the total supply, the total resistance, which is I, which is ROT, will be the sum of the individual what? Resistor, which means it will be what? Resistor R1, the sum of the individual resistor R2, and what? Resistor what? R3, which is the fourth property of what? Or behavior of a series circuit. The total supply, the total resistance is equal to the sum of the individual what? Resistor, which is what I just did here. So now I don't, which is the total supply, which is the total what? Resistor, which is total resistance, will be equal to what? Resistor R1, which is 2 ohms, resistor R2, which is 3 ohms, resistor R3, which is 7 ohms. So the total resistance, which is ROT, will be equal to 3 plus 7 is 10 plus 2 will be what? 12 ohms. So that is the answer. Then for II, which is IT, we are asked to find IT, which is the total what? Current. So for II, we will have that the total current from Ohm's law will be what? V divided by what? R, according to Ohm's law. So the total supply voltage is 12. And the total resistance, which we just calculate, is 12 ohms. So our current will give us 1 watt amps. So 1 amps of current flows through the what? Circuit. So the third one, which is, we are asked to find the voltage drop across what? Each resistor, which is the voltage drop. So the voltage drop, the voltage that will drop across resistor what? Other one, which is V1, according to Ohm's law, V1 will be what? I multiplied by what? R1. Which our current is 1 amps multiplied by what? The resistance value of what? R1, which is 2 ohms. Which 1 times 2 is what? 2 volts. So that is the value of what? Voltage drop. That is the value of voltage that we drop across what? Resistor R1. So the value of voltage that we drop across resistor R2, which is V2, will be equals to I1 multiplied by R2, which will be 1 multiplied by what? The resistance value of what? R2, which is 3 ohms, which will be what? 3 volts. So for V3, it will be what? I multiplied by what? R3, which will be 1, which will be current, multiplied by what? 7, which will be 7 volts. So these are the what? Voltage drop. Okay, let's confirm one of these property or what? Series circuit. We state that the total voltage is equal to the sum of the voltage drop across the individual what? Resistor. So now let us confirm which is Vt is equals to what? V1 plus V2 plus V3. To check whether this our answer is true, if we sum all of this voltage drop, our answer will give us this word 12 volt. To confirm that the total word, the voltage drop across the individual resistor will be equals to the word, the total supply voltage, which will be Vt, which Vt is 12. We know that Vt is 12, which will be equals to V1. So our calculation is 2 and V2 is 3 and V3 is 7. So now, let me clean here. So now, we will have that 12, which is the total supply voltage, will be equal to 3 plus 7 is 10 plus 2 is 12, which is 12 volts. That means the right hand side is equal to what? The left hand side is equal to the right hand side, which means the sum of the individual voltage drop is equal to what? The total supply voltage. That means the property of what? Series circuit is actually what? Correct. Okay, let us solve this other example. Let's solve this other example. Let's say we have a resistor like this. We have a resistor like this, and here is R1, here is R2, and here is R3. Okay, let's complete the circuit. And we have our value, which is I, and we have V, and we have 4 ohms resistor, we have 6 ohms resistor, and we have what? 10 ohms resistor. So we are asked to what? Find ROT, which is the total what? Resistance in the what? Circuit. So what are we going to do? First of all, whenever you are asked to find the total resistance in a series circuit, if you can add money, you can solve or you can find the total resistance of any one series circuit. Just add them like you are adding numbers. Just add the individual resistance like you are adding money. So it will be ROT, which is the total resistance of the circuit, will be what? 4 plus 6 plus 10. And it will give us what? 20 ohms. If you can add money, you can solve the total resistance in a what? Series circuit. Just add them like you are adding money. and your answer will give you the word total what resistance. Okay, what are the common mistakes students do make when solving CD circuit problem? They assume that current change across what resistor. They assume that the value of current changes across resistor, which is not true. In a CD circuit, current is the same throughout. In a CD circuit, current is the same throughout. It is the same amount of current that flows through R1, R2, and what? R3. One of the common mistakes students do make when solving CD circuit problem is that they use the reciprocal word formula like in parallel. When they are asked to find the total word resistance in a CD circuit, they use 1 over R, which is 1 over ROT, like they are solving for what? For total resistance in a parallel circuit. When solving for total resistance in a CD circuit, just add the resistor directly. There is no need for you to use 1 over R, which we are not solving for what? Parallel circuit. Okay, if you have watched this video to this extent, don't forget to like this video and subscribe for more electrical circuit world problems. This is just the beginning. Like this video and subscribe, and also share it to your friends and loved ones. Bye. See you in my next video.